The confirmation of 3I/Atlas as a natural interstellar comet marks a significant moment in modern astronomy, not because it represents danger or mystery in the popular sense, but because it deepens humanity's empirical understanding of the galaxy beyond our solar system. As the third confirmed interstellar object ever observed passing through the Sun's gravitational domain, after 1I/Oumuamua in 2017 and 2I/Borisov in 2019, 3I/Atlas offers scientists an unprecedented opportunity to study material formed around another star system, preserved for billions of years, and briefly revealed as it traverses our cosmic neighborhood. The object was first detected on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System ATLAS, a network of telescopes specifically designed to identify near-Earth objects and transient celestial bodies. Its discovery was routine in process, but extraordinary in implication. Early orbital calculations immediately revealed a hyperbolic trajectory, an orbital shape that cannot be produced by objects gravitationally bound to the Sun. This alone placed 3I/Atlas into a rare category, an interstellar visitor originating from beyond the Sun's sphere of influence, likely ejected from another planetary system millions or even billions of years ago. Hyperbolic orbits are crucial to understanding why claims that 3I/Atlas might return to Earth are scientifically unfounded. Unlike elliptical orbits, which define planets and long-period comets bound to the Sun, a hyperbolic path indicates excess velocity. The object entered the solar system on a one-time trajectory and will exit it permanently, never to return. Orbital solutions independently calculated by NASA's Jet Propulsion Laboratory, the European Space Agency, and observatories worldwide converge on this conclusion with remarkable consistency. As tracking continued, a global observational campaign was initiated. Ground-based telescopes and spaceborne observatories, including the Hubble Space Telescope, the James Webb Space Telescope JWST, SOHO, STEREO, and the recently deployed Punch mission, captured images and spectra of 3I/Atlas across multiple wavelengths. These observations conclusively identified classic cometary behavior, a surrounding coma formed by sublimating ices, and a tail composed of gas and dust streaming away from the Sun under solar radiation pressure. The presence of a coma was particularly important in distinguishing 3I/Atlas from earlier interstellar detections. Oumuamua, the first interstellar object observed, displayed no obvious coma and exhibited unusual acceleration, leading to years of debate and speculation. In contrast, 3I/Atlas behaves in a manner entirely consistent with known physical processes governing icy bodies exposed to solar heating. Its activity increases as it approaches the Sun and decreases as it recedes, matching established cometary models. Spectroscopic analysis, particularly from JWST, revealed a chemical composition dominated by carbon dioxide CO2, with measurable quantities of water vapor, carbon monoxide, and trace organic compounds. While this mixture differs from the typical water-dominated comets formed in the Sun's protoplanetary disk, it is not anomalous in a broader galactic context. The abundance of CO2 suggests formation in a colder region of its original star system, where volatile compounds could condense and remain stable. Such findings provide valuable comparative data for planetary formation theories beyond our own solar system. Polarimetric studies added another layer of insight. By analyzing how light scatters off the dust in the comet's coma, astronomers detected negative polarization signatures, features uncommon among solar system comets, but not unprecedented. These signatures indicate differences in grain size, porosity, and surface texture of the dust particles. Importantly, while unusual, these properties are well within the range of natural explanations and do not imply artificial construction or technological origin. Equally critical is what scientists did not observe. Precise astrometric measurements show that any non-gravitational acceleration, small deviations from the predicted orbit caused by asymmetric outgassing, is minimal and fully consistent with known cometary physics. There is no evidence of controlled maneuvering, thrusting, or course correction. The object's motion is governed entirely by gravity and natural outgassing forces, following predictable equations of celestial mechanics. Despite this robust body of evidence, public anxiety and speculation escalated rapidly, driven largely by online misinformation and selective interpretation of scientific commentary. Social media posts and sensational headlines suggested that 3I/Atlas might be on a collision course with Earth, or that newly calculated trajectories indicated a return path. These claims collapse under basic scrutiny. The comet's closest approach occurred on December 19, 2025, at a distance of approximately 1.8 astronomical units, around 270 million kilometers, placing it safely well outside Earth's orbit. At no point did orbital uncertainty place it within any credible impact corridor. Another narrative that gained traction involved claims of extraterrestrial technology. Much of this speculation stemmed from interviews featuring Harvard astrophysicist Avi Loeb, who has previously argued that some interstellar objects might represent artificial probes. In various podcast appearances, Loeb raised questions about perceived anomalies and suggested that certain high-resolution images, particularly one reportedly taken by the Mars Reconnaissance Orbiter's HiRISE camera, were not publicly released. However, such claims do not constitute evidence. Spacecraft imaging schedules are governed by technical constraints, data validation protocols, and mission priorities. Delays or non-release of specific images are common and do not imply concealment. More importantly, no peer-reviewed data supports the assertion that 3I/Atlas exhibits artificial features. Extraordinary claims require extraordinary evidence, and to date, none has been presented. The persistence of these theories highlights a broader issue in the modern information ecosystem: the gap between scientific consensus and public perception. Interstellar objects, by their nature, challenge intuitive understanding and ignite imagination. When combined with incomplete information and algorithm-driven amplification, speculation can overshadow careful analysis. Scientists involved in the study of 3I/Atlas have repeatedly emphasized transparency, publishing orbital data, spectra, and imagery through publicly accessible archives. From a scientific perspective, the true importance of 3I/Atlas lies not in fear or mystery, but in opportunity. Each interstellar visitor provides a direct sample of another planetary system's building blocks, without the need for interstellar travel. By comparing their compositions, structures, and behaviors, astronomers can refine models of planet formation, stellar evolution, and the chemical diversity of the galaxy. As 3I/Atlas now recedes from the inner solar system, its activity diminishes, and it resumes its silent journey through interstellar space. It will carry with it no messages, no threats, and no intentions, only the physical record of its origin encoded in ice and dust. The data it leaves behind will continue to be analyzed for years, contributing quietly but profoundly to humanity's understanding of its place in the cosmos. In the end, the story of 3I/Atlas is not one of impending danger or hidden intelligence. It is a reminder that the universe is dynamic, vast, and interconnected, and that even fleeting encounters can yield enduring knowledge when approached with rigor, patience, and evidence-based reasoning. Or mystery, but an opportunity. Each interstellar visitor provides a direct sample of another planetary system's building blocks, without the need for interstellar travel. By comparing their compositions, structures, and behaviors, astronomers can refine models of planet formation, stellar evolution, and the chemical diversity of the galaxy. As 3I/Atlas now recedes from the inner solar system, its activity diminishes, and it resumes